This is WebAssign number 1 for redox reactions, and we're not really doing redox reactions yet. We're going to do oxidation numbers. So here we go. The first question says assign oxidation states to the atoms, all the atoms in each of the following. So we look at NH3, and most of this goes back to what you know about oxidation numbers from, and they're actually just called charge numbers from way long ago. So we look at NH3. In most everyday things, what is the charge on H? H is mostly a plus. And let's see, 3 times a plus, if you do some math in your head, is a total of a 3 plus. And you have 1 nitrogen. Nitrogen is almost always a 3 minus. Does a 3 minus cancel a 3 plus? It does. So the nitrogen is a 3 minus, and the hydrogen is a 3 plus or a plus 3. Now let's look at the next one. CO2. In most cases, oxygen's a 2 minus, so 2 times 2 is a minus 4, and you have 1 carbon, so carbon must be a plus 4. So a plus 4 would cancel a minus 4. So we have plus 4 and minus 2. Moving right along. HClO4, we usually start from the outside and move to the inside, and it's that mystery one in the middle that we usually have to figure out because it tends to change its number. So oxygen for the most part is a 2 minus, and hydrogen for the most part is a 1 plus. So 4 times 2 is an 8 minus. 1 times 1 is a plus 1. So I think in my head, what must that chlorine be to cancel these two numbers? And it must be a plus 7. A plus 7 and a plus 1 would be a plus 8, which would then negate that. So we have a plus 1, a plus 7, and a 2 minus. And you can write that as 2 minus or minus 2. Either way works just fine. Let's look at this next one. K3PO4. K3PO4. Again, start from the outside and move to the inside. O is 2 minus or minus 2, so that's a total of a minus 8. And again, where did I get that from? 4 times 2, and that's a minus, so it's a minus 8. K is always a 1 plus, so 3 times 1 is a plus 3. This is my little accounting sheet where I'm keeping track of everything. So what must P be to make all this add up to 0? And I think it must be a plus 5. Because if it's a plus 5 and a plus 3, that adds up to a plus 8, which would then cancel out the minus 8. So we have a plus 1, a plus 5, and a minus 2. This next one says assign oxidation numbers again. We can do this. CO3, now these ones have a charge. If you need to put parentheses around it, go for it. 2 minus. So oxygen is almost always a minus 2, so minus 2 times 3 is a minus 6. What must this 1 carbon be to have it add up to a 2 minus? And that's where I'm getting that 2 minus from. It must be a plus 4. So if you have plus 4 and a minus 6, it will add up to a minus 2. So over here we put plus 4 and minus 2. Next one, NO3 minus. And again, if you need to put parentheses around it, that's fine. 1 minus. That's almost always a minus 2, so that's a total of minus 6. We have to add this up to a minus 1. This must be a plus 5. That's 5, and a minus 6 would add up to a minus 1. So a plus 5 and a minus 6. Let's look at this next one, PO4 with a 3 minus. Oxygen is almost always a minus 2, so 4 times minus 2 is minus 8. This has to add up to a minus 3. If you need those parentheses around that, that's fine. So what must this 1P be to make it add up to a minus 3? It must be a plus 5. So plus 5 and a minus 8 do equal a minus 3. So we have a plus 5 and a minus 2. Next one. SO4 2 minus. SO4 with a 2 minus. O is almost always a 2 minus. So 4 times 2 minus is a minus 8. And we have one of those. This must add up to a minus 2. What must that be? I think it's a plus 6. So plus 6 and a minus 8 will add up to a minus 2. So we'd put plus 6 and a minus, not a minus 8. Holy cow, not possible. A minus 2. Is that a 6? There we go. And again, you put the charge for each individual element. You don't do what I just did and put them together as a congregate. This ain't no congregation. Question number 3. What is the oxidation state of sulfur in each of these? So now we just have to find sulfur. And of course, they give you the hardest one of all, NaHSO4. There's a couple different ways you can do this. You can go back to what you learned a long time ago and look at your pink sheet. You know that Na is a 1 plus, just from your periodic table. And this you'd find on your pink sheet, that whole thing is a 1 minus. And so you could just work with the HSO4 if you wanted, and that has to add up to a 1 minus. And we go back to some things we know. We know that O is almost always a minus 2, so that's a minus 8. And that's a 1 minus. H is still a 1 plus, so we have a 1 plus. What must that S be to add up to a 1 minus? I think it must be a plus 6. So if we had plus 6 and a plus 6 and a plus 1, that would be a plus 7, and a minus 8, that would add up to a minus 1. So in this case, the S is a plus 6. How else could I have done this? That was one way. I broke it up into its polyatomic ions. Miss A sometimes doesn't like to work that much. I might do it in a different way. I might go, that's a minus 2, so we have a total of minus 8. That's always a plus 1, so I got a plus 1 here. Hydrogen's a plus 1, so I got a plus 1. What must this all be to add up to 0? It must be a plus 6. So we got plus 6, plus 1, plus 1. That's a plus 8 to cancel a minus 8. And so that's where I would have gotten that. A couple different ways you can do it. So you can check your work if you're feeling unsure about your thinking. Next one, H2S. Well, H is almost always a 1 plus. We have 2 of those, so that must be a plus 2. So what must S be to add up to a 0? It must be a plus 2. Because a minus 2. What are you thinking, Miss A? A minus 2, because that would then cancel that. So S in this case is a minus 2. And it generally is on the periodic table. Now this next one's thrown in there to see if you're paying attention. I believe that says S subscript 8. So any element written by itself, even if it has a subscript like this, always has a charge of 0. So its charge is 0. That's just the rule. The next one, SO2. I don't see a charge after that, so SO2. O is almost always a minus 2, so 2 times minus 2 is a minus 4. This has to add up to 0, so that must be a plus 4, because then those would cancel each other out. Let's look at the next one. What is the oxidation state of chlorine? Who doesn't like chlorine? Let's do it in a glorious green, because I always think of green when I think of chlorine. So NH4Cl. Well, chlorine is almost always a 1 minus. Let's see. If we call that a 1 minus, that a plus 1, so we'd have a 1 minus, a plus 4, and then I think N is what it always is a minus 3. That would add up to be a minus 4 to cancel that, so I think chlorine's a 1 minus. That one was just what it was on the periodic table. In fact, chlorine's pretty boring on here. HCl, H is a 1 plus, chlorine, what we've always learned, is a 1 minus, so chlorine's a 1 minus there. It's not changing so much as it. So this one's HClO. Now it's in the middle, so that's usually an indication it might not be a 1 minus. Minus 2 plus 1, so my math, I got a minus 2 and a plus 1. It has to add up to 0. I think this time it must be a plus 1, which is totally weird for chlorine, but it happened. That would cancel out to be 0. So it's a plus 1. This next one, HClO3. We'll start at the ends again. O is a minus 2, so we got a total of a minus 6 there. H is a 1 plus, we got a 1 plus there. This must add up to 0. I'm guessing it's a plus 5, because those then would add up to cancel that. Question number 5. What is true about the species that is oxidized in an oxidation reduction reaction? So if you are oxidized, Leo, the lion goes grrr. loss of electrons is oxidation. So if you are oxidized, you lose electrons. Is that a possibility on there? So it can't be it gains electrons. I'm not talking about oxidation number yet. It loses protons, has nothing to do with protons. It does, it loses electrons, has nothing to do with protons. Does its oxidation number get larger? Yes, if you lose negatives, you become more positive. So the oxidation number gets larger. Question number 6. In any redox reaction, the substance that undergoes reduction will, I'm not sure what these selections are. So in any redox reaction, the substance that undergoes reduction, so let's think about what reduction is. I always have to go back to my Leo, the lion goes GER. So reduction is a gain in electrons. If we gain electrons, I've got to go back to my modus pototus. Gain electrons. Okay, so it's one of these bottom two. It'll gain electrons and have a decrease in oxidation number or an increase in an oxidation number. If you gain electrons, you're becoming more negative, so your oxidation number would decrease. Let's look at the next problem. The following redox reactions occur spontaneously in an electrochemical cell. Which species loses electrons? So a loss of electrons means you become more positive. So zinc became more positive. Zinc is the one that lost electrons. Which species, I can't say the word very well, gains electrons? So if you gain electrons, you have a smaller oxidation number, you become more negative or go in the negative direction. So chromium 3+ went to a chromium 0, so that one must be the other one. Now we're looking at zinc. Zinc went from a 0 to a 2+. It lost electrons. And Leo, loss of electrons is oxidation. So we lost electrons, so it was oxidized. So zinc was oxidized. By default, the other one must be the one that's reduced, but let's check. Reduced means you gained electrons. If you gain electrons, your number becomes more negative, and it went from a 3+ to a 0, and that's going in the negative direction, so it was reduced. Moving on to question number 9. Indicate which substance is being oxidized and which is being reduced. We look at magnesium. Magnesium is going from a 0 to a 2+. It lost electrons. Loss of electrons is oxidation. The lead went from a 2+ to a 0, so it gained electrons. And gain of electrons is reduction. Moving on to the next one. I- went from a 1- to a 0, so the number got bigger. And here Miss A has an issue. She moves on to the iron. Iron was a 3+ to a 2+. The number got smaller, so that's a gain of electrons. Gain of electrons is reduction, so Fe was reduced. Back to the Fe, or the I, that I was having issues with. I went from a 1- to a 0, so that means it's actually getting bigger, and it means you're losing electrons, and loss of electrons is oxidation. Number 11. Identify these creatures as oxidized or reduced. So we look at sodium. Sodium's going from a 0 on that side, because it's all by itself. When it's by itself, it's a 0, unless it has a charge written to it. And on that side, sodium is what it is on the periodic table, a plus. That's a loss of electrons, which is oxidation. And the next element they give you an option of is hydrogen. Hydrogen on the right-hand side is a 0, and in that compound it is a 1+. So it gained electrons. It was reduced. Moving on to chlorine. Chlorine, and this next one, Cl2, is a 0 because it's written all by itself and there's no charge written next to it. So chlorine went from a 0 to a 1-. Just look at the periodic table for chlorine is. It gained electrons, which is reduction. Therefore, the other one must be the one that is oxidized. Let's double check. It went from a 1- to a 0. Oxidation is loss of electrons, and it became more positive because it lost its negatives. The next one, chlorine, went from a 0 to a 1-. It gained electrons, so it was reduced. And the iodine should be the opposite one. It went from a 0 to a 1+. it lost electrons, it was oxidized. The next one is cesium. It went from a 0 to a 1 plus. Loss of electrons is oxidation. Fluorine went from a 0 to a 1 minus. Gain of electrons is reduction.